we are going to do we are done with chapter 1, just give you a notion of the sets and the functions. So we get to the main part, which is 2.1, chapter 2. In chapter 2, as we talk about it, we are going to see the alphabets of our communication. We are going to communicate with the machine just using the propositional logic or formal logic. So we're going to introduce the language. Each language would have an alphabet. Okay, we use the alphabets to create the language. Okay, and then we're going to make a sentence, or we are going to show how we're going to communicate. So it's going to be a number of the definition that we are going to cover. Okay, it's quite interesting and quite useful for us. Okay, so let's do it. So formally it is section 2.1. We try to see whatever we can today, and so we can prepare you for a short quiz, which is going to be next week. Okay, so let's see how far we can go. I will post the practice quiz and then the assignment that we're going to collect, everything. Okay, let's see how far we can go today. Okay, formal logic, the language of the communication. If you are going to communicate with a proposition, so what is the definition of a proposition? Okay, propositions. A proposition is going to be a statement. It's going to be a sentence with one condition. That sentence will give you a news. That news, you should be able to identify it as a true or false. Okay, so any sentence, any statement that contains a news that can be considered as a false or truth, not both of them, is going to be called a proposition. Okay, so definition of a proposition, a statement. Okay, a statement or a proposition. Or a proposition is going to be, we need a news, it's going to be a declarative containing a news. Okay, sentence. Okay, it declares something for us. It's going to be a declarative sentence that is going to be either true or false, but not both. But not both of them. So clearly you should identify this is if the statement is going to be true or a statement is going to be false. Okay, if this statement is given to you, then we're going to call it a proposition. Okay, give you some examples of the propositions. So the following statement, the following are going to be our propositions. Propositions. Okay, we go with the first one. The first one, for example, LA is in USA. It's a sentence, give you a news, and that news is, okay, is true. So LA, Los Angeles, is in USA. Is a sentence, and we can consider that's going to be true. Okay, it's true. So this is a proposition. Any question? Give you another one. The second one. The second one is something like London. Okay, London is in France. It is a sentence containing a news, but that news, of course, is false. Since this statement can be considered as a false statement, So this is going to be a proposition. Okay, any question? The other one is a statement that 2 is less than 4. 2 is less than 4. It's an statement, and this statement is true. So this is going to be a proposition. Okay, this statement is true. So this can be considered as a proposition. Okay, and another one like number 4, something like 5 equal to 7. 5 equal to the 7 is a statement, but of course it's false. Okay, this statement is false. So therefore, this is a proposition. Any question? So a proposition is going to be a sentence containing a news. That news is true or false. If you can identify it true or false, so in that case, you are going to have a proposition. Let's have some sentences that are not going to be proposition. Okay, so give you some, just give you an idea, you compare them together. So the second group, this is your first assignment, you get a number of them in your book. And so in this part, we want to check, or we know that the following are not propositions. Let's see what's wrong with this statement. Okay, let's checking the first one. The first one is this statement. What's your name? You see, what's your name? What is your name? You see, this is a statement, but it's not something that give you a news, which is going to be true or false. It's just a question. Okay, it's a statement that there is nothing that you can consider it to be true or false. So in that case, this is not going to be a proposition. Okay, it's not a proposition, it's just a question. Okay, it is a question. It is a question. Okay, so precisely you should be identified that the news that carrying by this statement is going to be true or false. Right? There is no news in this one. Okay, any question? Give you another one just to compare, to get the idea of what's going on. You see this one? Do your homework. Do your homework. You see again, this is a statement. There is nothing in it that's going to be true or false. Okay, so this is just a sentence and a statement. It's not going to be a proposition. It's not a proposition because again, there is a not fact that's going to be considered to be true or false. It's kind of, you can call it, it's a command, okay? I command you to do your assignment. Okay, so this is not the case. If you like, you can say that it's an order. Okay, it's an order, it's a command. So you cannot consider this to be to be a statement. Any question? This next one is interesting. Look at this one. This sentence, this sentence is going to be, this sentence is false. This sentence is false. What's wrong with this one?
It's a paradox.
What do you mean? Which part is the paradox?
Oh, well, if it's false, then the statement has to be true,
Yes.
but it can't be true because it says it's false.
Yeah, no, it's good. It's neither true or false, if you like. Okay, because it should, if it's going to be a proposition, it must be true or false, not both of them. But yes, in this case, it's kind of a product. Okay, so it's neither, if you like, just give you the reason that we rejected is that it is, okay, it's going to be neither or neither true or false, if you like. So this is going to be, the case. Any question? This next one is also interesting. What's wrong with this one? X is an even number. X is an even number. What's wrong with this one?
There's no way we can say it's true or false.
It can be either one depending on what X is.
Very good. Yes. Yes. X, it depends on X. Okay, it depends on X. What is X? Okay, we don't know the X. So it may be, we just say that we reject it. We reject it because this is statement because of the X. If it was true, we know that 2 is an even number. If it's going to be 3, we know that 3 is not an even number. When it's X, we don't know. So it depends. Okay, this statement depends on what X, if you like, represents. So that's why we reject it. Okay, so that would be our tool or the definition of a proposition. Any question? Now, what we are going to do now, we get the alphabets. Okay, we get these sentences that we call them propositions. We assume that we have some of these sentences, if you like. Okay, like we have the foundation or we have the alphabets. So what we're going to do is we are going to combine them together to make more propositions, if you like. So we refer to these propositions as a kind of atomic one. Atomic one means these are going to be the one that does exist. But we are going to use some connectives like in everyday life to combine them together. Okay, to combine them together. When you combine them together, we are going to make some more, not complicated, bigger one if you like, of these propositions. So these original ones can be considered as let's say atomic one. And if you have a collection of atoms together, you're going to have molecules if you like. Okay, so what we are going to do with these basic propositions, we put them together and we get a bigger one. We are going to use some connectives, like in English language, and connectives are going to be what? We can connect it by and, or we can use or if you like. Okay, I go shopping and, I'll go shopping and I watch a movie. Okay, so I go have a, what's that? Have a fries or a soda, something like that. So what we are going to do, we are going to introduce those connectives, which is going to be very important for this course, to put them together and to have some nice one, okay? So we are going to use some symbols, okay, some notations, and these connectives together. Okay, so let's go for it. So let's give you the introduction of the connectives first. Okay, so what is going to be connectives? So this is going to be what we are going to do. We are going to assume we have some atoms, atomic one, some basic one. So in so-called propositional, okay, propositional logic, this logic that we talk about it, Personal logic, we assume that we have some of them. So we assume a collection. Okay, we assume a collection of atomic. A collection of atomic propositions. Collection of atomic propositions are given. Okay, we call them atomic. They're just the basic one, the small one. Okay, they are going to be denoted by, we are going to denote them by the lowercase letters. Okay, P, Q, R, S, T, etc. So if you see this type of notation, these are going to be the given one or the basic one. Then we're going to put them together to make something bigger. Then what we can do is we form a new one. We form a compound. Okay, we form compound propositions. Okay, by using connective and these atomic one. By using logical connective. Logical connectives. Logical connectives, and sometimes we call them logical operators. Or like a function. Logical operators. Okay, logical operators to have a bigger one. To have, you know, that the combination of atoms would be called molecules. So to have a propositional molecules. Okay, that's it. You know, this expression that we use to get the connection, if you like. Start with the atoms and we get the molecule ones. Now this big one, we have a special notation for it. So compound propositions usually use the uppercase letters. Are going to be denoted by, this is it, okay, the capital letter, P, Q, R, etc. So these are going to be notation through the course that we're going to use for these type of operations that we're going to have. Okay, any question? So what is going to be the connectives? We're going to introduce the connectives. We introduce the notation for the connectives, and we put them nicely together. Okay, so I'm going to give a table and I introduce all of them at once. In your book, they talk about each one of them. You can read it, but this is what we need. Make sure you have enough space for this table. Okay, so this is it. What is going to be logical? What is logical connectives? Logical connectives. Okay, so what I need this type of table to introduce to you all of them. So I start with the name of the operation. This is going to be the name that I'm going to use. Then I'm going to introduce a symbol. So I'm going to represent it by to give you that notation, and then I will give you the meaning of each one of them. Okay, these are going to be other tools that we're going to use. Okay, are you ready? The first one is called negation. Okay, that's it, the negation. Negation, the notation that we're going to use is this one. This is in your book, negation of the P. but I use this notation, or maybe both of them. That's it, negation of the P. The second one is more popular. Okay, and when you, if you want to call it, you call it not P. Okay, not P. Not P. Okay, so we can say the negation of the P or simply not P. Negation of the P or not P to get these numbers. Okay, so this is going to be the first one. Okay, the next one. So just give me 1 second. I have to open the door. Okay, so we go to the next one. The next one is called the conjunction. Okay, that's it. Conjunction. That is going to be the next one. The notation that we're going to use is going to be P and Q. Okay, conjunction or P and Q. And this is the way we are going to call it, P and Q. P and Q. A more popular one in your book, and we are going to use it from time to time, is going to be or P but Q. P but Q. Okay, so we can say that the P and Q, you can say P and Q or P but Q. Both of them is going to. Sometimes this would be making more sense, or the sentence would be nice or nicer if you like, but we can use both of them. Be ready for it. Okay, so this is going to be, we call it and connection. And connection. Okay, question. We need the or connection, we call it disjunction. That is going to be disjunction. Disjunction. Disjunction is going to be or connection. So it's going to be P or Q. P or Q, and this is exactly how we are going to call it. Okay, that's it. We call it P or Q. Okay, this is going to be P or Q or both. So this is how we're going to use it. So it's going to be the case that, you know, we get a P or Q or both of them. This is the one we call it this junction. If you want to drop the both, you have to another one. We are not going to use this one, but you need it sometimes in your discipline. So we're going to give you this one. Another version of this one is called exclusive or. Okay, that's it. Exclusive or. Exclusive or, sometimes you may have to use it. The notation for the exclusive or is this one. You say the P plus Q. You have to put it inside a circle, but this is the one. Sometimes, you know, during the assignment of your book, you may see a couple of them, but I'm not going to use it. This means either P or Q, not both of them. Okay, if you want to exclude that both, you have to use the exclusive or. Okay, so the exclusive or means either P or Q. Okay, or P or Q, either P or Q. Okay, but not both. But not both of them. Okay, that's going to be, no, that's going to be the case. You say it's like, you know, when you order something in a restaurant, you order it and they say that, you know, you can have a soup or, you know, or something else. So you cannot say I want both of them. When they talk about it, they mean exclusive or. Okay, if there's going to be a situation mathematically that we use, mathematically when we use, we consider also the both. So that would be this conjunction or P or Q. Okay, so just just give you this one in case you need it in future, but we are not going to work with this one. Okay, this is exclusive or. Any question? Have a couple of more to go. The next one, a quite interesting one for all the theorems that we're going to use. The next one is called implication. Okay, implication. Another name for it is conditional. Okay, that's it. It's going to be conditional. Conditional statement, we call it. So implication or conditional is the one that we are going to use all the time. You see P implies Q, or if P then Q. Means if the P is given to you, then you have to follow the Q. Okay, P is happened, so you must do the Q if you like. Okay, if you work hard, you get an A in this course. So working hard implies that you get an A in this course. There's going to be if P and K. So the condition that you get a good grade in this course is working hard. So that's going to be the case that we're going to use it. All the theorems in mathematics is of this format, implication one. So this is how we are going to call it. This is it. We say if P, okay, if P then Q. If P then Q, or P implies, most of the time you use this expression, or you can use the expression that the P implies. P implies Q. So you can use both of them. If P then Q is more popular, but in your book you see lots of statements. Okay, just doing that P implies Q. So we are going to use both of them. Okay, so that's going to be the implication. And the last one is biconditional one. Biconditional. Biconditional is going to be, this is it. It's the one that we call it if P, if and only if Q. That's it. So this means if P then Q and if Q then P at the same time. Okay, so that's a biconditional one. Sometimes some theorems would be biconditional, means you can have both sided. Okay, you can have the theorem and its converse. So in that case, we are going to use the biconditional property, and then this is the way we are going to call it. It's going to be P, if and only if. If and only if Q. Okay, P, if and only if Q, and sometimes we use this short version, or P, if and only if. This is the expression that we use, P, I, F, F, Q. So that would be the biconditional situation I'm going to have. Any question?
Very quick question. So basically the biconditional P and Q are dependent on each other. Both of them are the conditions, basically?
No. We are going to define it.
Okay.
That's just the symbol for the time being. This means if P, this means P implies Q and Q implies P.
Yeah, basically they are each other's conditions, right?
Yeah. It's, the implication that you have is just a single one. You see, if P then Q. If you also have the converse, if you like, then if you have both of them at the same time, that would be a biconditional one.
I see.
You see, some theorems are two-sided, if you like, but some are not. You see, if a function is differentiable, that function is continuous. But the converse is not true. If the function is continuous, you cannot say the function is differentiable. So in that case, you don't have the biconditional one. You have only the conditional one.
Got it. Thank you.
Yeah, all the definitions in mathematics are biconditional. Okay, but you have to have both of them to be able, to talk about it. Okay, so these are going to be our tools. So don't be surprised. Your job, some of these expressions are given, and we give you just a couple of them on the quiz. We want you to kind of transcribe or translate. We may give you in English formats, then change it to the symbolic one, or we give you the symbolic one and we ask you to read it and write it. So you must be precise, okay, the expression that we're going to use. So anytime you have something with the implication, you have to start with this expression, if, then, okay, or this is going to be if and only if. Those or and words that we use over here are going to be important. Okay, let's give you one so that you know what's going to be our expectation. And you will see in your first quiz, 2 different formats. We give one question and we ask you to translate it. And make sure that you stay with the rules of the game, if you like, the one that we define here. Okay, don't use anything of your own idea, if you like. You have to be in this because we're just dealing with the machine. Okay, so everything must be precise. So we may give you this and you will see these type of problems in your practice quiz. They are going to define some of these expressions. Okay, so they say, suppose P means cruise. Okay, cruise ships. Cruise ships only go on big rivers. Okay, only big rivers, so that's going to be P. Then they find the preposition Q to be this one. Q is cruise ships. Okay, cruise ships go on the Hudson River. Okay, Hudson. That's it, Hudson. Okay, so that's going to be the second one. And there is a third one, R. R is that the Hudson River. Okay, the Hudson is not. Okay, Hudson is not a big river. A big river. Okay, so these are given to you. Then they may ask you to read some of these expressions, okay? So for example, then they may ask what is going to be P and Q. Any suggestion? Put them together, give us in word form if you like. Anybody wants to try? That is P and that is Q.
Cruise ships only go on big rivers, but cruise ships go on the Hudson, maybe?
Yes, and or but. Yes, P and Q. P is just to repeat it. Okay, that's it. Cruise ship only go on big rivers, if you like. Cruise ships only go on big rivers and okay, go on the Hudson because you have the and here. Okay, or cruise ships only go on big rivers. Okay, go rivers, but okay, go on the Hudson. But we just use with the end. Okay, so that's it. It's you have to repeat it. Cruise ships only go on big rivers. And this part is important for us. And when I want to grade it, I check to see if you use the proper connective. Okay, and go on the Hudson. Or you can repeat it, cruise ship go on the Hudson. Okay, so this is going to be the combination that we're going to have. So don't be surprised, but make sure you get it right. Any question? Try this one. The next one is P and Q implies R. P and Q implies R. Okay, anybody wants to try this one? Implication. Since it's a conditional one, you have to start with the if. Okay, if the first one, then the second one. Okay, so let's make sure to use the if. So this is it. If, that's it. Cruise ships only go on the big rivers and go on the Hudson, then R would happen. What's the R? Then the Hudson is not a big river. Okay, so since it's an implication, you have to start with the if. So if, so you bring the first part. The first part is if cruise, okay, if cruise ships only, just repeat it, only go on big rivers. Okay, go on the big rivers and go on, okay, go on the Hudson, then the second one. So it's very crucial to use the if over here. Okay, you just finish the first statement, the second statement you're done, you use and, then the result, then the Hudson. Okay, then the Hudson is not a big river, not a big river. So this is going to be your job. This is the way you're going to translate. Okay, you should be able to do it the other way around too. So this is going to be the problems that we are going to have. Okay, so the other option is, I like this one, we start with the if. If you want to use the implies, you can start with the first one, cruise ship only go on big rivers and go on Hudson, implies that the Hudson is not a big river, but we prefer if then. Okay, if then, as we talk about it. Okay, any question? So you see 2 questions on your practice quiz number 1 that I'm going to post it. Then for the translations from going one to the other one, just look at the terms to be precise. Okay, otherwise everything else is going to be clear. Question? Now, the next question is going to be, when we work with this original one, remember the atomic one, since they are proposition, so we know that this proposition P is going to be either true or false. This is the same for the Q and the R. So we want to know when you combine them together. When you combine them together, how are you going to determine the truth values, if you like, of the result. So this is going to be your key tools for the problem of this course. Okay, so I'm going to give you something we call it truth tables. So we're going to consider different cases, and we give you all the truth tables of the compounds propositions. Okay, so this is going to be your tool. So what's going to be truths? Because for the original one, you know it. Okay, the atomic one, you know it because they are propositions. But what would happen if you combine them together? Again, in your book, they talk about each one of them one by one, but we give you all of them at the same time. Okay, so we need a nice table. Make sure to get enough space. Okay, so what I do is I'm going to consider I'm going to consider the proposition P. Then I have the Q. So I give you not P, the negation. Then I give you P or Q. Then I give you P and Q. Then I give you if P then Q. Okay, and I give you P if and only if Q. These are going to be all of them at the same time. So you follow these rules from now on for this one and the next 2 chapters. Okay, are you ready? Let's see. We're going to consider different cases. Okay, the case that suppose you know that each of these atomic propositions can be true or false. So we are going to consider what would happen to this result. Suppose P is true and the Q is true. If P is true, then not P would be false. Negation. You see, that's one. So if a proposition is true, the negation of that proposition would be false. If the proposition is false, the negation would be true. P or Q. You see, P and the Q are true, so P or Q would be true. P and Q, both of them are true, so it's going to be true. If P then Q, both of them are true, so this is going to be true. And P and the Q, if and only if both of them are true, so that give you true. So that's going to be case 1. Any question? That's straightforward for this case. Now the other possibility for these two, there are 4 possibilities. 4 possibilities, you see, true, 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 false, false, true, false, false. So you have to consider both of them, okay? So the next one, true, false, true, false. P is true, so the not P is false. P or Q. You see, P or Q would be true if at least one of them is true. Since the T is true, so this would be true. P and Q would be true if both of them are true. But one of them is true, the other one is false, so this would be false. This would be false. If P then Q, you see, if P then Q means if you have the P, then you have to do the Q. So if true is going to be, if P is going to be true, so P is happened. So you have to follow the rules. So if P is true but Q is false, this means this is going to be false. Because you cannot get something false from the, okay, from the fact, if you like. You see, if it's raining, I have to take my umbrella, if you like. So it's already raining, so you have to follow the rules. So this is true, it's raining, but you don't have your umbrella. So this happens. That's why this is going to be false. Okay, so the first one must happen. This is the only time that you get the false statement for this one. And the next one is going to be false, because if you switch it, you see if this P, if P then Q is going to be false, the only time that this is going to be true if both of them are the same, if you like. So this would be false. Because one of them is true, the other one is false. Any question? This is a kind of controversial one for this one. Otherwise, the next one is going to be, this is false. This is true. Okay, if P is false, then the not P would be true. P or Q, because one of them is true, so this is going to be true. P and Q, one of them is false, this is false. Oh, that's interesting. You see, if P then Q. Remember, if P happened, you have to follow the rules. P is false. P is false. This means P didn't happen or does not happen. So this means you can do whatever you like. You can go and watch a movie, okay? Because there is no implication on you, okay? You don't have to do anything because it's false. So in this case, this is going to be true. And this has happened quite a lot. Make sure you understand it. So if the implication starts with a false statement, this is always true. This is always true. Okay, it's going to be always true. So this means if I don't come to the lecture, you don't have any implication. You can go, okay, and you can go and watch a movie. You can go, sightseeing, because I didn't come to the class. If I do come to the class, you have to be there. Okay, since I didn't come, you are free. You can do whatever you like. There is nothing on you, okay, to follow the rules. So this is, again, the crucial one. So if we start with a false statement, it's always true because you don't have anything to obey, if you like. And again, for the P and the Q, because one of them is true, the other one is false, this is always false. Okay, and the last one, if both of them are false. If both of them are false, the negation of the false is true, of course. P or Q, both of them are false, so this is going to be false. A P and Q, both of them are false, this is going to be false. Again, you start with the false statement, so you don't have anything to obey. Okay, this is going to be true. If for the implication the starting one is false, there is no application for you to follow any rules. You can do whatever you like. P and the Q, because both of them are the same, so this is going to be true. This is the table. Any question? So your job is make sure don't miss the if P then Q. You see, a P then Q is only false if the first part is true, the second one is false. Because if the first one is true, you have to obey the rule. So the first one is true, but the second one is false, means you didn't obey the rules. So that's the only time that you get a false statement. Otherwise, it's always true to get these numbers down, okay? A P or Q is always true. P or Q is going to be true if at least one of them is true. So the only time it's false is both of them would be false. P and Q would be true if both of them are true. Both of them are true. Otherwise, it's always false. And of course, P and Q, P if and only Q, they must have the same truth values. Both of them to be true or both of them to be false to get these numbers. Okay, any question? So this is going to be your, okay, your tool, if you like. Make sure you know it, and it should be available for all the problems of this course. Okay, so I'll just give you one example to see, and the one that I talk about it, and the one that you may feel a little bit uncomfortable about it is this one. Remember, if this statement is given to you, if it is, okay, if it is raining, then I am, okay, I am wet, if you like. I just want to translate it and to give you this table. So if you consider the first one to be P, the second one to be Q. Okay, so the symbolic form of your statement is going to be what? Is going to be if P then Q. So this is what you have. So if you want to find out what's going to be the truth table of this statement, this is how we're going to identify it for us. Okay, the truth table. This is going to be P, this is going to be Q, and this is P or Q. Just check that situation that we did talk about it. And we know that if it's going to be true, this is true. If it's going to be true, false, So this means P is given to you, but you didn't follow the rules. So this is the only time that you get a false. You cannot get a false news or the false case from the truth implication. Okay, and the second part is going to be false true. Since you start with a false statement, the result is always true. Because P didn't happen, so we can go and watch a movie. So it's a true. And the last part, false, false. So again, you start with the false P, so this result is going to be true. So this is going to be, you know, the truth table of this statement that we're going to have. Okay, any question? So yes,
Could you please explain the third line one more time? I'm not fully grasping it.
this one,
Yeah, the P is the F and the Q is the T.
that's about. You see, this means this is called conditional one. This is statement. So this means if P is given to you, then you get the Q. Okay. So in this part, P is false. When P is false, this means, okay. So this means this didn't happen, if you like. When the P is false, when it's going to be false, you are not going to get the Q. You see? So if P is given to you, you have to follow the rules. So what you have the P is false, but Q is true. So this cannot happen. So in that case, this statement is going to be true to get these numbers. You see, what does it mean? Look at this one. What does it mean? When the P is false, what does it mean? P is false means it is not raining. Okay? It is not raining, but you have to, it's not raining, but you are wet. That's why this statement is going to be, okay? So since it's not raining, you don't have any obligation to follow. You see, it is not raining. What was your obligation? Your obligation was you must be wet. So since it's not raining, you can do whatever you like. You see, in this case, it's not raining, but you are wet. But in this case, this statement is going to be true. Because if the first one is happened, the second one must follow. If it is raining, I am wet. It's not raining, so what are you going to do? It's not raining, you may be wet, you may not be, okay? You cannot be wet, okay? That's going to be the one, because it's not going to be raining. So it's not raining, you can do whatever you like. It's not raining, I go and watch a movie. So the statement is going to be true, okay? So that is going to be the nature of this second part. Any question? That was good for you?
Yeah, thank you.
Mathematically, it's going to be very useful for us in future that we're going to use it. You see, if the first one is true, you have to follow the rules if you like. If it's going to be raining, so this means P is given to you. P implies Q, This means you are going to be wet. But since the first one is false, means it's not raining. So you don't have to be wet. You can do whatever you like. Okay, you can do whatever you like. So it doesn't matter whether this is true or false, because you don't have any obligation. Look at this one. False, false, you get true or false. The result is true all the time, because you didn't have any obligation to follow. So you may get wet, or you may not. Or you may go and drive a car. Okay, you go and drive shopping because of the first one, which is false. So as soon as you see the false, the result is true all the time, because you're going to be free. Okay, so look at this one, the second part. The second one, the first one is true. So this means it's raining. It's raining and you must get wet. But it's raining, but you didn't get wet. So this means you didn't follow the rules. That's why it's false. Okay, any question? So we get quite a lot of this, and mathematically it's going to be such useful for us. And make things easy for you. As soon as you see the false P, you don't have to worry about to check the second part. You just write it's true and then you go on and do your job. Okay, any question? So again, we have some statement, we put them together to get this definition. I want to make sure you get one more definition to go on. Now, when you do these tables, okay, look at this that we're going to have. These are like a function. In fact, in computer science, there are some cases that you don't like to use the symbol true or false, because this is a function. Remember the function? The function is a machine. You drop something in it, you get something out. The function over here, you drop the P and the Q into the machine, the output is going to be true or false. So some people, instead of true, they use symbol 1. When it's a false, they use 0. So they give us a table of 0, 1, 0, 1, 0, 1. So they say 1, 1, 1, 1, 0, 0, 0, 1. They describe it is going to be just using these symbolic terms, which is, it's okay. It's a function. The range of your function is just 2 symbols, true or false. The range of 0, 1 is just 0, 1. Okay, so this idea of the truth tables is a function. Is a function that give you the result. So when you're dealing with this function, okay, when you're dealing with this function, the situation is going to be, you see the output of your function is true, false, true, false, true, false. Sometimes you may get a function, you may get a situation you're going to have that the last part, the true tables is true, 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 true. I can give you an example in a minute. So if you get true, 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 this statement is true all the time. We have expression for it. The expression is tautology. So tautology is going to be a compound proposition, which is true all the time. You may get false, 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 0, 0, 0, 0. In that case, the statement is always false. We call it a contradiction. And sometimes you may get 0 or you may get 1, 0, 1, 0, 1, 0, 1. In that case, your statement is called contingency. Contingency, if you get true, false, true, false. Contradiction, if you get false, 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 false. Tautology, if you get true, true, true. Okay, so this is going to be 3 important expression, and you have quite a lot of these type of ideas in your book, and of course 1 question on the first quiz and the test. Okay, so let's define these expressions to finish with this, so that you get to start working on your assignment. What is tautology? We are in that section. It's a very dense one. What is tautologies? Just make sure you get it right. Tautologies, always true. Contradiction, always false. Contradictions, always false. Or contingency, sometimes false, sometimes true. Okay, contingencies. Okay, 3 famous expression that I have to know it. So let's give a brief expressions of all of them. A compound. Okay, compound proposition or a statement. A compound proposition is going to be called, okay, called a, first one, tautology. Tautology, not self-tease. Okay, tautology, sorry, that's a logy. That's a tautology, that's a Y. Okay, tautology, if it's always false. If it is, sorry, always true. It's going to be always true. Okay, tautology, always true. That's the first one. The opposition of a tautology. the opposition to a tautology. Tautology is going to be, of course, a compound. Okay, a compound proposition. Compound proposition that is always, that's always false. It's always false. Okay, always false, and we are going to call it contradiction. Called a contradiction. Contradiction. Okay, always false contradictions. And the other one. And if it's going to be something in between, okay, sometimes false, sometimes true. Like a function that I talk about, that function, the range is 1, the range is 0. But it's going to be 0 and 1. It's going to be a, okay, that would be a contingency, a compound proposition. Compound for proposition shows truth value. Okay, truth value is not constant, if you like, is not constant. Not constant means, you know, it's not always true or not always false, or maybe sometimes true, sometimes false, okay, is going to be called, a contingency. Contingency. Okay, it's not constant. It may be true or it may be false. That case, you know. When you want to check it, if you get true or false, you stop. But if you get true, that would be tautology. False, 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 that would be a contradiction. Okay, your main job, we give you 3 in 1 question, 3 a statement, and you're going to check it for us. You have to draw a table. Okay, we need a table to prove your, you know, your claim to get these numbers. Any question? Are you ready, for example? That's it. Determine if the proposition is one of these. Determine if the proposition, determine if the proposition is going to be is a tautology. It's going to be a tautology, contradiction, or a contingency. Okay, remember, you are going to use the table to give us the information. Don't just say tautology. You have to prove it. Prove tables. Okay, the first one is very popular. P and not P. P and not P. Draw a table. This is, you know, just you have to give us the range of the function if you like. So the solution is going to be get the table. This is it. In your table, you need the P, you need the not P, and you need the result, which is P and or but not P. Consider the possibilities. For the possibility for the P is going to be true or false. You see, if P is true, this is going to be false. This is AND combination. Remember, AND combination is going to be true if both of them are going true. Since one of them is false, so the result is going to be false. Okay, that's going to be one. What do you want? Page back after the example. You mean this one? This is it. You have a chance after. Okay, then I come back, when I'm done, if you like, if you want. So this is how we're going to arrange it. So that's it. P is true, not P is false. One of them is false, so the result's going to be false. The other possibility is false. If this is false, it's going to be true. So one of them is false. This is going to be false. That's it. So we get false, false, false. So this means P and not P. P and not P is a contradiction. Is a contradiction. And you're done. Okay, this is the way you are going to prove it for us. Question? So this is going to be the first one. This second one is very popular, and we're going to use it, later on. But we're checking just for the time being. How about P and not Q? You want to check this one? Again, draw your table. Check to see what's going on. Solution. So get your table. So what you need the form, the P. You need the P and the Q, P and the Q. You need the not P, not P. Then you need the result, P and not Q. Now consider different possibilities. You have two atomic propositions, so you have to consider 4 cases. Okay, consider your cases and then you put them together. So the cases start with the true, true. This is going to be false. P and not Q. Since one of them is false, the and the result is going to be false. Any question? Let's get the other possibilities. So the other possibility is going to be, if this is going to be true, this is going to be false. So in that case, the not Q would be true. So we have the P and the not Q, both of them are true. So it's going to be true. You see, you stop. You don't have to continue. Because if you continue, you see, you have the false and the true. So it's a contingency right away. Okay, it's going to be a contingency and we stop here. So, you can go on if you like, but you don't have to. The other possibilities are going to be, we get a false true. Okay, and we get the false false. But you don't have to because you already got the, you already got the 0, 1 if you like. So you stop here and you claim that P and not Q is a contingency. You save time. You don't have to go on. Contingency. Okay, any question? So if it's happened to be false, we have to consider, continue. You may get, false, false, false. But since the function is not constant function, if you like, remember these are going to be function, the result. That's 0, 1, or false or true. So in that case, we have a contingency and we don't have to continue. Any question? Let's have another one. What we need? Contradiction, contingency. Let's see if we can get a tautology. So the third one. The third one is this one. We have P or not P and Q. Okay, you need a little bit more bigger table to consider. Remember, you are not going to change this as is. Okay, in future, you are going to have some properties, but we want to see how you handle this type of situations. So you have to give us a table to check it. You have two proposition, atomic proposition P and the Q. So we have 4 possibilities to get these done. So get a nice table. Okay, so let's see what we need. So we need a P, then we need a Q, P and Q. We need a P and Q here. P and a Q. And we need to make a negation of the P and the Q. Negation of the P and Q. Okay, and then we need the result, which is going to be P or not P and Q. Okay, break it into parts, okay, and then get what we need. Okay, so let's see what is going to be a situation. Are you ready? So fill the table. So this is it, true, true. True, true, both of them are true, so this could be true. Okay, the negation of the true would be false. And this one over here is or combination or, okay, and this is false, but this is true, this is going to be true. Remember, in case of the or combination, it's going to be false if both of them are false. So one of them is true, the P, so this is going to be true. Okay, get the other possibilities. The other possibilities, but if it's going to be, let's say, true, false. The order is not important. You can write them in an order you like. So P and Q, one of them is false, so the AND combination would be false. The negation of the false would be true. And this one, you see, this is or combination. One of them is true, of course, both of them are true, but one would be true, you get true. So we're going to continue because we get true, true. So we may get a tautology. So we have, if you get true, false, you stop. That give you contingency. But this one, we continue. Okay, we continue, make this one into the false, true. Okay, the combination again is going to be false. It's like the previous one. This would be true. Since one of them is true, so it's going to be true again. Okay, one more case to go. The last case is going to be false, false. Okay, we get a false, false, both of them are false. This is going to be false again. So this is true again. So one of them is true, so the result is going to be, the result's going to be true. That's it. So we have a tautology. Okay, so the statement of the P or not P and Q is going to be a tautology. This is a tautology. And then we're done. Any question? So this form of the table, we are going to use it for a while. So that's fine to make sure you get it. Okay, I should give you one more. Any question? So let's have one with the implication. So that's a number 4. So we give you one question on the test, on the quiz. It's going to be 3 parts, and you will see it again on your test 1. And you get quite a lot in your assignments. Okay, let's check this one. Not P and P or Q implies Q. We want to check to see if this is going to be one of those cases that we talk about it. Just want to do it so that you know how to take this implication. Remember, the implication is going to be true all the time, except if you start with the true statement and you end up with a false. because the first one, if this first one is going to be true, you have to do the second part. Okay, get the table for this one. Your table would have a little bit more terms. So you need the P, you need the Q, you need the P, oh, we need the negation of the P, negation of the P, we need the P or Q. So we need to combine them together. It's going to be not P and P or Q. And eventually the result, not P and P or Q implies Q. Okay, so this is going to be a situation we're going to have. Okay, any question? Are you ready? 4 possibility for the P and the Q to get this result. Okay, the first one, true, true. This is false. P or Q, that give you true. This one over here, you see the not P and. Since the not P is false, this is automatically would be false. For the implication, you see, when you start with the false, it's always true. Because when it's start with the false, this means the implication didn't happen. So you can do whatever you like. Okay, remember, if this is false, you don't have to do anything. So this statement is going to be true. Question? The other possibility, true, false, true, false. This would be false. You see, you don't have to consider this one, but this is true again. Since the not P is false, so this would be false. Again, if you start with the false, the statement is always true. Okay, so we may go over the tautology. So check this one, false, true. So the not P would be true. P or Q, one of them is true, so it's going to be true. Okay, so both of them are true, so it's going to be true. So this is true. How about Q? Q is also true. Okay, so true, true, that give you true again. Okay, so the starting one is true. You have to look at the Q. The Q is also true. True, true would be true. Okay, and the last one, false, false. This would be true. Both of them are false, so this is going to be false. One of them is false, so this is going to be false. And if you start with the false statement, okay, implication, the result is always true. That's it. So it is a tautology. Okay, so the expression is going to be, it is a tautology. Tautology. And you're done. It's a very, very nice one to get this type of ideas. That's it. We are done with the section 2.2.1. There are a couple of more things to cover, and that would be 2.2. So there are more definitions that we talk about it. You see, so far we defined the idea that we have. So what we would like to do, would like to make some formulas. In order to make formulas, you need a kind of equality. You can say that something is equal to the other one. So you have to tell us how we're going to compare this expression together. Okay, if two compound propositions given to you, how are you going to tell us they are equal? The expression that we're going to is going to be equivalent. So what's important about these? The important part about these are the truth values. So if you have two compound propositions for which the truth tables of both of them are the same. So if the truth tables of the first proposition is the same as the second proposition, we are going to say that these propositions are equivalent or they are equal. So as soon as we get the equality, then we can bring some formulas. Okay, so this is the idea of the section 2.2. So I try to do that one too, and then I go over the practice quiz. Let's see how far we can go. But we would like to give you the quiz at the end of that would be section 2.2. So we get this is where we give you the quiz. Okay, I post the quiz, practice quiz number 1. I also have a solution to that at the same time I post it so we can have a look. But we finish that section and we collect the assignment up to this is chapter 1, 2 sections of chapter 1, 2 sections of chapter 2, 2.1, 2.2. This is the way we are going to end up this week. Okay, study it carefully. If you have any question, let me know. And at the same time, look at the practice quiz that I'm going to post. You should be able to do a couple of those problems even with these ideas. Okay, that's it. Any question? So have a good one. Start working on the those problems and the practice quiz that we're going to set. Okay, the problems in your book is not bad. Some of them are tricky, and the way they are going to express it sometimes is different. But have a look. If you have any question, bring it in. Okay, I have to drive to CSU San Marcos now because I have a face-to-face class for the first time. Okay, take care and see you on Wednesday. Bye-bye.
Thanks. Bye.
Thank you, Professor.
Thank you, Professor.
Bye, have a good night, Sal.